Good morning, Booth Dog here. Happy Thursday. As we continue to spend most of our time at home, I continue to explore a plethora of musical instruments. Today I've been playing this lovely frog. It was a delightful little gift from my taiko sensei several years ago. Anyway, I love the sound of it. I hope it brings you a little fleeting joy in the midst of everything that's going on today. Let's bring Mr. Boothman on. Get started. Good morning. Happy Thursday. We're almost at our unit exam. Today's exit ticket will ask you to submit any questions you have from this review specifically by midnight tonight. I'll try to put together some responses to your FAQs and post those in the morning so you have those as a reference while you're taking your exam. Just a reminder that that exam is tomorrow, and there is no unit tracker due this unit, okay? All right, so for today's lesson, I do want to go through a few problems from the Unit 10 review, both parts A and B. I specifically chose these problems. I think they're good example problems for the concepts that we'll be testing. So looking at the Unit 10A review, I'm looking at section 1, the very first two problems. So we are stating whether the series diverges or, if it's convergent, what it converges to. So here's our first series. We have the sum from k equals 2 to infinity of 5 times 1/3 to the k power. This is a geometric series. Since it's a geometric series, this value in here, what we're raising to our power, is our common ratio. Okay? So our sum, the sum of any geometric series, when our common ratio is between -1 and 1, is a1 over 1 minus r. That means we need to find our first term, which means we need to plug in our first value for k here, which is 5 times 1/3 to the second power. So our very first term here is 5 over 9. So our sum is 5 over 9 over 1 minus r is 1/3. This is 5 over 9 all over 2/3. Dividing by fraction means multiplying by the reciprocal. Okay, so we do that and we simplify and we get 5 over 6. So this series converges, since the absolute value of r is less than 1 and it's geometric, to 5 over 6. Okay. Looking at number 2, on that same page, we have another geometric series. We're looking at r here. Is the absolute value of r less than 1? No. So the series diverges. Okay. So some examples of geometric series, things to look for. Let's move on to section 2, and I'm going to do the first problem there. So this is relying on your knowledge of those power series and Maclaurin series that I asked you to memorize. We have f of x equals x times e to the x squared power. Okay. Now, we know the Maclaurin series for e to the x, and into that series we can plug in x squared, and we'll multiply that whole series by this x. So let's do x times. We have the series for e to the x, but anywhere there's an x, we are plugging in x squared. So we have 1 plus x squared plus x to the 4th over 2 factorial plus all the way x to the 2n over n factorial. Continue. Okay. And then distributing in that x plus x cubed plus x to the 5th over 2 factorial plus ... plus x to the 2n plus 1 over n factorial plus ... Okay, so just recognizing how we can split this up, recognizing the series that we should know, and how to manipulate that into something useful. Okay, the last problem I'd like to go through from the Unit 10A review is the very last page in Section 3. I want to do the second to last multiple choice question. All right, so it wants us to provide the coefficient of x cubed in the Taylor series for e to the 3x about x equals 0. Okay. Well, the coefficient of x cubed means that if we're looking at that specific term in the Taylor series, we have f triple prime of a times x minus a cubed all over 3 factorial. Well, a in this case is 0, and we need f triple prime. So if this is f of x, then f prime equals 3 e to the 3x. F double prime equals 9 e to the 3x. F triple prime equals 27 e to the 3x. And that's just following from the chain rule. Plugging in 0, we get e to the 0, which is 1, so just 27. So this turns into 27 times x cubed all over 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So if we want the coefficient of x cubed, we're looking at 27 over 6. If we look at our multiple choice selections, this is not one of our options, which means we might need to simplify this. Both are divisible by 3, so we get 9 over 2, which is answer E. And there we go. All right, so Unit 10A, that was looking at Taylor series and our Taylor polynomials, power series and Maclaurin series I asked you to memorize, and your geometric series and when those converge or diverge. Second part of the review, Unit 10B. All right, I am looking at the very last problem on that first page, problem 5C. All right, so we had this function, f of x equals 1 over 1 minus 5x. Okay, we wrote out the first 4 terms in the general term of the Taylor series for this function at x equals 0. We looked at the interval of convergence. The very last part asks us to show that the approximation of 5 over 8 for f of negative 1/4, it has an error less than 1/5. An error less than 1 over 5. Now, it's important to remember that formula that we had before. Our function value equals whatever this Taylor polynomial is giving us plus our remainder. So if we're trying to show that our remainder has some value less than something, that's the same thing as showing, just moving stuff around, that this f of x minus p of x is less than a certain value. Well, p of x here, we're told, is 5 over 8. And f of x, f of negative 1/4, well, we know f of x, so we can plug in this to our function. And we're trying to show that this, the absolute value of this, is less than 1/5. So finding f of negative 1/4, subtracting 5 over 8, taking the absolute value, this is approximately 0.1805, which is less than 1/5. So that's the only work that we need to do here. Okay, it's recognizing this relationship here. Very last problem I'd like to do in this review is the very next problem after that 5C. So the second page of the Unit 10B review, Section 2, number 1, we're asked to show if the series converges or diverges, and to tell which test we used. So we have the sum from n equals 1 to infinity of n plus 1 over n factorial. All right, so nth term test doesn't really tell us if a series converges. It will only tell us if it will diverge. This is not a geometric series. Alternating series test, this is not an alternating series. So we need to look at the ratio test. So looking at the ratio test, remember that the ratio test is asking us to evaluate the limit as n approaches infinity of the absolute value of the n plus 1th term. Okay, I'm actually gonna, well, we'll write it up. N plus 1 term, so I'm plugging in n plus 1 for n, over the nth term. Dividing by fraction means multiplying by the reciprocal. So we end up with the limit as n approaches infinity of n plus 2 over n plus 1 factorial times n factorial over n plus 1. Now remember that n plus 1 factorial is the same thing as n plus 1 times n factorial. So that cancels out, and we have the limit as n approaches infinity of, now we can drop the absolute value, there's no x here, and n is restricted to values from 1 to infinity, so of course it's always positive. That means we have n plus 2 over n plus 1 times n plus 1, which is n squared plus 2n plus 1. We can't evaluate this, we would get infinity over infinity, so I'll apply L'Hopital's rule, and we get 1 over 2n. Now, if I attempt to evaluate this as n goes to infinity, we get 1 over infinity, which is 0. So this is our limit. And since our limit is less than 1, this series converges. Okay? So, please, I'm not asking you to do the rest of your practice problems. I know there are quite a few, but the more you do, the more comfortable you'll be with all of this. So take this seriously, keep working. Come to our Google Meet if you have any questions. Complete your exit ticket by midnight tonight and be ready for our review. I'm sorry, not our review, our exam tomorrow. Have a great day. All right, well, I can never get over how brilliant Mr. Boothman is. Anyway, hope you're enjoying your lessons. Keep it up, keep pushing yourself. Join our Google Meet with any questions you have, and I'll see you tomorrow.